In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Okay, today I'm going to discuss my lecture number 42, oil and gas production, exploration, production, upstream, midstream, refining, petrochemicals, differentiated performance, enabling profit optimization process, lecture number 42. Okay, before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue, that they may understand my sayings. Allahumma Rabbi zidni ilma, O Allah, advance me in my knowledge and true understanding. Okay, from my next slide, I'm going to run a trail, what we have planned to discuss, and then I will run a complete trail on my today lecture. Okay, oil and gas productions. Oil and gas productions. So introduction, we have already discussed. Reservoir and wellhead management system, upstream facilities, midstream facilities, refining facilities, petrochemicals, utility systems, and unconventional conventional resources and environment effects. So today we are discussing this area, and this is my last lecture on unconventional conventional resources and environment effects. So we have already discussed introduction, facilities and process management systems, reservoir and wellhead management system, upstream facilities, midstream facilities, refining facilities, petrochemical, utility systems, and now we are discussing unconventional conventional resources and environment effects. What is the ultimate goal? Shaping the clean and sustainable global energy delivery. Plan to deliver a 300 lecture in the next couple of years. This is my 42 lectures, and remaining lecture we will complete next couple of years. Okay. Gas production, unconventional conventional resources and environment effects, lecture number 42. Today we have planned to discuss 3 topics: indigenous emissions, greenhouse emissions, carbon capture and sequestrations. Okay, key takeaway points from lecture number 42, indigenous emissions, greenhouse emissions, and carbon captures. Okay. Indigenous emissions. The indigenous emissions from industry can be divided into several types. Today we are going to discuss only 4 types. Okay, what are these 4 types? First is discharge, and second accidental spill, and third emission, and fourth here exposures. Okay, these are 4 topic types we are going to discuss today. First is a discharge. What is discharge basically? Okay, the discharge basically mud, shale, sillet, produced water with trace of hydrocarbons, blast waters, polluted wastewater with detergent, sewage, etc. Second, the accidental spill, blowout, shipwreck, cargo and bunker oils, a pipeline leakage, other chemical traces of low levels radioactive isotopes. Number 3, emission, carbon dioxide, CO2, methane, nitrous oxides, NOx and SOx, and sulfur from power plants and flaring. Number 4, exposures, toxic and or carcinogenic chemicals, Locally, these emissions are tightly controlled in most countries by national and international regulations and during our normal operations. Emission targets can be reached with the systems and equipment as we have discussed in my earlier slide. However, there is continued concerns and research into environment impact of traces levels of hydrocarbons or other chemical on the reproductive cycle and health of wildlife in the vicinity of oil and gas installation. The major short-term environment impact is from spills associated with accidents. These spills can have dramatic short-term effects on the local environments with damage to marine and wildlife. However, the effects seldom last for more than a few years outside rocky regions. Now we're going to discuss greenhouse emissions. The most affected greenhouse gas is water vapors. Water naturally evaporates from the sea and spreads on can amplify or suppress the other effects because of its reflective and absorbing capability. The two most potent emitted greenhouse gases emitted are CO2 and methane because of its heat trapping properties and lifespans in the atmosphere. Methane's effect on the global warming is 22 to 25 times higher than CO2 per kilo released to atmosphere. By order of importance to greenhouse effects, CO2 emissions contribute 72 to 77%, methane 14 to 18%. Nitrous oxides 8 to 9%, and other gases less than 1%, as we can see through Wikipedia and UNEP. The main source of carbon dioxide emission is burning of carbon hydrocarbons out of 29 billion tons. Many publications we can see the teragram TG million tons of CO2 emitted in 2008. 18 billion tons or about 60% of total comes from oil and gas. The remainder is coal, peat and renewable bioenergy such as firewater. 11% or 3.2 billion tons comes from the oil and gas industry itself in the form of losses, local heating, power generation, etc. The annual emissions are about 1% of a total atmosphere CO2, which is in a balance with about 50 times more carbon dioxide dissolved in seawater. This balances depend on sea temperatures, oceans, CO2 storage in reduced as temperature increases, but increases with a partial pressure of CO2 in the atmosphere. Short term, the net effect is that about half the CO2 emitted to air contributes to an increase of atmosphere CO2, about 1.5 ppm annually. For methane, the largest source of a human activity-related methane emission to atmosphere is from rice paddies and intracts fermentations in ruminant animals, dung and composite from 1.4 billion cows and buffaloes. These emissions are estimated at 78.5 tera per year sources out of a total of 200 tg, which is equivalent to about 5,000 tg of CO2. Methane from the oil and gas industry accounts from around 30% emissions, mainly from losses in transmission and distribution pipeline and system for natural resources. This picture demonstrates annual greenhouse gas emission by sector. If we can see the first here, the first 16.18% industrial processes here. Second, a power station 21.3% here. And number 3, waste disposal and treatment 3.4%. And land use and biomass of burning 10%. And residential, commercial and other sources 10.3%. And next is fossil fuel retrieval, processing and distribution 11.3%. And next, agriculture bioproducts 12.5 and transportation fuel of 14%. Okay. No addition to that, if we can see here the further carbon dioxide emissions, methane and nitrous oxides, that is SOx and NOx. So if we can see here, the carbon dioxide here is almost 72% and methane here is 18% of total, and nitrous oxides, NOx, that is 9% of total. Okay. Greenhouse emission, first we'll discuss the model. Okay. This sun over here. So this is the area where the energy is reflected to space. This is the water vapors, evaporated and precipitations. Okay. So this is my CO2 atmosphere. From over here, absorptions and origins and sedimentations, and over here a volcano releases. Okay, so the fossil fuel here and CO2 in the biomass, and over here emitted energy to space, and this is my cosmic rays from methane removals and ozone's productions. Okay. Okay, this is my organic sedimentations and marine life, and fossil hydrocarbons here, and this is the co-radioactivity. Okay. Okay, there are many mechanisms affecting the overall balance of greenhouse gases in the atmosphere. CO2 has been measured both directly and in ice cores and has increased from pre-industrial value of around 250 ppm to 385 ppm part per million. Methane has increased from 1732 to 1774 part per billion. There is no full model that describes the net effects of these changes. It is well accepted that without CO2, methane and water vapors, the global average temperature would be about 30 degrees C colder. The current data correlates with the current global average temperature increase from a pre-industrial global average from 13.7 degrees Celsius to 14.4. The atmosphere and the sea have a large heat trapping capacity. With makes their temperature rise. These temperatures rise lag behind greenhouse gas temperatures increase. It is therefore predicted that the temperature will continue to rise by about 1 degree C even there were no further increase in levels of CO2 and methane gases. The heat capacity of atmosphere and the seas also means that when the temperature increases, there will be more energy stored in atmosphere, which is expected to drive more violent weather conditions. The main contribution to sea level change in the short to medium term is a thermal expansion of the oceans, currently predicted to have reached about 0.15 meter over a pre-industrial standards and currently rising some 3 mm per year, although the melting of inland ice in Greenland and Antarctica is reported. This will mainly have local effects as this ice will possibly take 15 to 20,000 years to have any significant contribution to sea levels. However, polar glaciers and sea ice is important indicator of global warming, and in particular summer's temperatures have risen and sea ice has been significantly reduced in area and thickness as well. Okay, from next slide we'll discuss carbon capture and sequestrations. Okay, due to these effects and the long-term concerns, it will be a high priority to reduce the amount of carbon dioxide and methane releases into atmosphere and to develop a more sustainable energy sources. The main problem is that as much as 1/3 of all emissions come from planes, cars, and ships, which account for about 45% of emission from hydrocarbon fuels that are not replaceable by other non-energy sources. Okay, there are three main areas. Okay, these problematic area, number one, there is losses in production. Only about 70% of hydrocarbons extracted from the ground reach the private or industrial consumers. The rest is lost from production systems, transportation, and through the refining and distribution of oil and gas. Number two, there are losses in consumptions. Much of the oil and gas is converted to work with an efficiency of 30% in cars, for example, to 60% in best power plants. Number three, better methods of capturing and storing emissions must also be found. Okay, efficiency will be improved by maintaining and operating facilities to reduce losses and by converting to more efficient systems. For example, it can be argued that converging to electrically driven equipment in place of gas turbine driven equipment could reduce CO2 emissions by more than 50%, even if power is generated by gas turbines and steam combined cycles. This also moves the emissions to centralized unit rather than distributing to a larger number of smaller gas turbines. To reduce overall emissions, carbon will have to be separated from other emitted gases such as water vapors and stored. Current plans call for reinjections into empty reservoirs or reservoirs that need pressure assistance for oil extractions. Okay, this was my last slide. So now we will conclude our today's presentation. Okay, today we have discussed indigenous emissions, greenhouse emissions, and carbon capture and sequestration. Okay, so next up, a recap in conventional and unconventional sources of energy. Okay, references: Qatar Petroleum, Doha, Qatar, Oil and Gas Development Corporation Limited, Pakistan, World Energy Outlook, US Geological Survey, US Department of Energy, Schellenberger's, International Energy Agency IA, Wikipedia, Oklahoma State Margin Emissions, Pumpers Manual, State Oil Facts and Nordic Standard, Standard Norway, Story of Oil in Pennsylvania, Air Liquid Gas Encyclopedia, Natural Gas from Wellhead to Wellhead. Together, everyone achieve more. Please do not hesitate to send your feedback, comments to.masood.dear at both.edu. You can also send your input through WhatsApp. I have also provided my WhatsApp number. Thank you very much and stay blessed.